The question is, in hydrogen spectrum, the shortest wavelength in Balmer series is lambda. The shortest wavelength in bracket series is what? So we have, for hydrogen spectrum, we have equation for wavelength as 1 upon lambda equals to RH 1 upon n square minus 1 upon m square, where lambda is wavelength, RH is Rydberg's constant, n is lower orbit, m is higher orbit. Okay, so for shortest wavelength in Balmer series, the value of n is equal to 2 and value of m is equal to infinity. So it will be 1 upon lambda Rydberg's constant. What is n square? 2 square minus what is m square? Infinity square. So therefore 1 upon lambda will be equal to Rydberg's constant 1 upon 4 minus 0. So therefore the value of 1 upon lambda will be equal to RH upon 4. Now for shortest wavelength in bracket series, we have the formula 1 upon lambda will be equal to, here I am writing it as lambda dash for bracket series, RH, which is Rydberg's constant, 1 upon, for bracket series, n we are taking 4 and m will be infinity. Okay, so therefore 1 upon lambda will be equal to 1 upon lambda dash will be equal to RH 1 upon 16 minus 0. Now in place of RH, what we can write? See, check here. In place of RH, we can write RH equals to 4 upon lambda. Okay, so 1 upon lambda dash equals to 4 upon lambda multiplied by 1 upon 16. So this will be equal to 1 upon 4 lambda. So therefore the value of lambda dash will be equal to 4 lambda. Okay, so the right option is option C.